Hi, my name is Sher and I'm a Math SCT tutor. I've heard that the Oxford MAT exam is really difficult, so today I'm going to try my hand at it without studying. If you like to watch these sorts of videos, be sure to subscribe so you'll be notified of further videos. Alright, so here is the Oxford MAT and I'm going to see how hard or how easy this is going to be. Alright, so this is the Oxford MAT and I'm going to be doing my best to solve it. So let's just start at the first problem. A square has center 3, 4. Center 3, 4. And one corner at 1, 5. Another corner is set, so if you just draw another line down here, 2 to the left, so 2 to the right, 5, 1 above, so 1 below, 5, 3. Answer's 5, 3. And of course they don't have that point, that would have been too easy. Alright, let's just find the slope of this. This is a negative 1 over 2. So we have a perpendicular line. Since diagonals in a square are perpendicular, this slope would be 2, and then point slope form y minus 4 equals to m, which is 2. 2 minus x minus 3. Y equals to 2x minus 2 times negative 3 minus 2. Alright, the point that fits this equation is our answer. 2 minus 2, 10 minus 2, 8 minus 2, 4 minus could work, and this one, 10 minus 2 is not 2. Answer's just D. Okay, let's look at this one. What is the value of this integral? We'll do difference of squares first. So ex squared minus x squared, and then dx. And then if you integrate, e to x 1/2 minus x cubed, but 1/3 x cubed, 0, 1. Okay, and then plug it in. So 1/2 e squared minus 1/3 minus 1/2 e naught plus 1/2. Nope, nothing. Alright. Combine these. 1/2 e squared minus 1/3 minus 1/2. The denominator 6. 3e squared minus 2 minus 3 minus 5. That's it. It's gonna be D. Alright, let's look at this one. Sum of this equals to, can we use geometric? What's this? X squared, negative x, no. Negative 1, x minus 1, x squared. This won't help us at all though. The sum this equals to, can we make it all positive or all negative? I have to think. Negative. Oh, okay, I see. 1 minus 4 plus 9 minus 16 plus 25 minus 36 plus 49 plus plus 99 squared is 9801 minus 10000. Alright, so if we group them up, 1 minus 4, negative 3, 9 minus 16, negative 7, 25 minus 36, negative 11. I did not write this one. So 49 minus 64 would be negative 15. And this one, it's going to be negative 199. Alright, so basically sum of arithmetic sequence. So sum of an arithmetic sequence formula is number of terms divided by 2, first term plus last term. So in this case we've got 100 to 100, so 50 pairs over 2. First term is negative 3, last term is negative 199. We will have 25, negative 202. And this is well, I mean, just looking at the last, we have to multiply 50 times negative 101, which is negative 5050. That's it. That's our answer for E. Right, let's look at this one, largest value. So if we have some y equals to 3 cos square x plus 2 sine x plus 1, Pythagorean identity, sine square plus cos square equals to 1. If we change everything to sine, 3 minus 3 sine square x plus 2 sine x plus 1, combine like terms, negative 3 sine square x plus 2 sine x plus 4. Gonna have to differentiate. One sec. So we'll use a substitution. U equals to sine x, negative 3u square plus 2u plus 4. So if they want the largest value, we probably are going to do dy over dx. dy over dx is negative 6u plus 2. So when this is 0, u would be 1/3. So we just have to plug in as 1/3. Y equals to negative 3 1/9 plus 2/3 plus 4, which would be negative 1/3 plus 2/3 plus 4, 1/3 plus 4, 4 and 1/3, which is 13/3. Alright, 13/3. So that's for this page. Alright, let's look at the next problem. So a line is tangent to the parabola at this point, where that's the area of the region bound by the parabola, the tangent line, and the x-axis equals to, so this graph x equals to, so it should look like this. And at a square, region bound by the parabola, the tangent line, and the x-axis. Okay, I'm going to draw a much zoomed in version. Like this, and then if we're talking about this point right here, the tangent would be like this. So we're talking between the curve, this line, and this. Okay, so there's going to be a long problem. Y equals to x squared, so the gradient dy over dx equals to 2x, so probably the slope would be, so when at that point it intersects at a squared, so the slope at that point is going to be 2a because x is a. Let's find the equation of that line. Y minus a squared equals to 2a times x minus a. Y equals 2 ax minus 2a squared plus a squared. Y equals to 2ax minus a squared. So when y equals to 0, 0 equals to a, and also 2x minus a. So this line will intersect, so this means a equals to 0, and we're not looking for a, my gosh, the variable is x, not a. Okay, so we have 2x equals to a, x is just a half. Alright, this point is a over 2. Okay, that's a start, and this point over here is a. Okay, we have that so far. We can just find the area under this graph to a and then subtract this triangle, I guess. So okay, graph first. So graph would be from 0 to a, x squared dx. So if we integrate that, we get 1/3 x cubed 0a. So the area of this whole thing is 1/3 a cubed, and then the triangle here would be 1/2, base is a over 2, height is a squared. That's going to be a cubed over 4. So it's just 1/3 a cubed minus 1/4 a cubed. So do I have space for that? A cubed over 3 minus a cubed over 4. That is just 1 over 12 a cubed. Is there that option? C, that's it. Alright, that's for E. Let's look at F. Oh. Which of the following expressions is equivalent to that? Log 10, so obviously it's just log 10 10 plus log 10 9 plus log 10 8 plus dot 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 all the way to log 10 2 plus log 10 1. Alright, and what did they put here? So we either have 2s, 6s, and 4s. We've got log 10 10, which is 1, log 9 10 9, log 9 8. Do we have to break it to 2s, 6s, and 7s? Okay, that's interesting. Oh, I see. Plus, so 2 log 10 3 plus, and 8 is 3 log 10 2. 7 is a prime number, so you can't do anything. Log 10 7, so obviously it's not A or E because there's no log 10 7. You can't really break down 6 log 6 plus log 10 5 plus log 2 plus 2 log 10 4 log 10 3 log 10 2, and well, log 10 1 is, my gosh, I can't remember my basic rules, and plus 0. Okay, so we just have to combine all the like terms. 1 plus log 3 3, that's 3 log 10 3 so far, plus 3 2 1 6 log 10 2, and then plus log 10 7 plus log 10 6 plus log 10 5. And plus all of that. But there's no 5 in any of the answers. Maybe we just do 10 over 2. Log 10 over 2 is just going to be log 10 minus log 2, log 10 2, which would bring this to 5 and bring this to 2. Okay, so far we have this. And which one looks the most similar? Log 10 2, they got rid of all the 3 because I get it. So 2 plus 3 log 10 3 plus 3 log 10 2 plus 2 log 10 2, and then all of that again, log 10 7 plus log 10 6. So if we combine these two, we would have 3 log 10 6. So if we combine 3 log 10 6 and another one here, we should have, overall it should be 2 plus 2 log 10 2 plus 4 log 10 6 plus log 10 7. Is there an option that looks like this? 2 2 4, that one. 2 2 C. Okay, that was a bit long, it took a while. Let's look at this one. A cubic function has this and a turning point of that for some d. What is the value of d? Cubic equation has those turning points, 1 2 3 d. Alright, so dy over dx equals to 3x squared plus 2ax plus b. And when, let's find a and b. So if we plug in dy dx as 0 and 1, so 0 equals to 3 plus 2a plus b, and also 0 equals to 927 plus 6a plus b. We just have to solve for a first, and then we'll solve for b, and then we'll solve for d, I think. So if we try to solve this, if we subtract, we should get 0 equals to 24 plus 4a. and then we should get a equals to -6, and if we plug in one of these, we get 0 equals to 3 minus 12 plus b. B would equal to 9. And then let's just, so we know A, we know B, and we just have to find C next. So we know the point 1, 2, so 2 equals to 1 plus minus 6 plus 9 plus C. So what is C? So 9 minus 6, 3, 4, C equals -2. We just have to find D now. So D equals to 27 plus 9 times 6 minus 54 plus, and then 9 times 27 plus, and what is C? Oh, minus 2. So we've got 27 minus 54 plus 27, they all cancel out. D is -2. Alright, and let's look at H here. Which graph is a plot of hx? The following 5 graphs are in some order plot of y equals to fx, y equals to gx, y equals to hx, y equals to df, and y equals to dg. That is 3 unknown functions and the derivatives of the first 2 functions. What graph is a plot of h? Okay, so 1, 2, 3 turning points. This one should have a 2 turning point one. So if we use this 1, 2, 3 turning points, it should start positive and then get to 0, positive, and get to 0 and then turn. It doesn't cut. The 1, 2, 3 should have 3 turning points. A and E are out because A and E are a pair. Like E is the derivative of A, so it likely is not going to be A or E. Okay, and then we also have to find, oh, and this one, and so if you have 2 turning points, then the derivative has 1 turning point, so it's definitely not C. We just need to find which one's the integral of C. It starts from a positive slope, so positive, that's not B, so these 2 are a pair. These 2 are a pair, so our answer is going to be D. Alright, let's look at the next problem. So we've got how many values of x for which the sum to infinity equals to tangent? So u equals to tangent x, u to the power of -1 plus u to the power of -2 plus u to the power of -3 plus ... has to equal to u. And r here is 1 over u, which has to be less than 1. Okay, so let's form the sum to infinity formula is a1 over 1 minus r. So in this case, u equals to u to the power of -1 over 1 minus u to the power of -1. Should cross multiply. U minus 1 equals to 1 over u. U squared minus u minus 1 equals to 0. U equals to 1 plus minus square root 1 minus 4 1 -1 over 2 1/2 plus minus 1/2 plus minus square root -1 5 over 2. There we go. Okay, so if 1 over u has to be less than 1, u has to be greater than 1. So that means u has to be half plus square root 5 over 2. So tangent x must equal to 1/2 plus square root 5 over 2. If it's -90 to 90, which is A and C, can't be in the 4th quadrant, it has to only be in the 1st quadrant. The answer is just going to be B. Okay, great. Let's look at J. Consider a square with side length 2 and center 0, 0, radius r, but do we know r? Oh, okay, it varies with r. A is inside the circle but outside the square, and B is inside the square but outside the circle, which is AR plus BR. Okay, first of all, the area can never be 0. We can't have 0 plus 0. It's not B and it's not E. Alright, and then if let's just plot the graph first. So if we start from R0 first, so if this is the square and this is the circle, which is very small, so when R is small, we should have 4 minus whatever it is, pi r squared, quadratic downward graph. It's not going to be C then. Okay, and what happens if the circle is so this is when R is small, and when R is very big, we have the other way around, the circle minus the square, pi r squared minus 4, which should look like this instead, which is not A. This has to curve up, so it has to be D. Alright, and I think that's the first portion of the entire Oxford MAT portion. And that's it for part 1. It took me about 20 minutes, and actually it was quite easy. So if you enjoyed watching the video, be sure to leave a like and subscribe so that you get notified when I attempt parts 2 and 3. Thank you for watching.